In this one I will do an inverting amplifier using OPAmp. So this is the circuit diagram. This input is Vi and this is the operational amplifier here. So this is the inverting input and this is the non-inverting input. The non-inverting input is connected to ground. I have labeled it as V2. So V2 will be equals to 0, and the current here, the current that is flowing because of the voltage source is going this way, but then this current will flow in this direction, the same current, because current cannot go, the current into the input is 0, both of the inputs. Since the currents are 0, there will be no current in this direction, so the same current will flow in this direction. So from here this is going that way. So this point's voltage is V1, so if we say the current as I can say I is equal to, from just Ohm's law, this is V1 here, Vi here, and this is V1 here, so Vi minus V1 over R. Similarly again, using Ohm's law, this is V1 here and this is V0 here, and current is going in this direction, so we can say also I is V1 minus V0 over R. Now since V2 is 0, we know for an OPAmp there will be no drop here between the inputs, so V1 is equal to V2, we know that. So since V2 is grounded, V1 will also be grounded, so that should also be 0. So from here this equation we can write, since V1 is 0, I is equal to Vi over R, or from here since V1 again this is 0, so this part is 0, so this we can write V0 over R. So now if we rewrite this I, so both are I's, so I can write this thing as Vi over R I is equal to minus V0 over R F. Did I write RF here? RF it will be, of course, this is RF, did a mistake here, because this resistance is RF, this one is RF, so yeah, this will be RF. So then I can write V0 over V1, Vi, sorry, as minus RF over R. Now this is the output voltage and this is the input voltage, so the ratio is gain, voltage gain. So we see that the voltage gain of an inverting amplifier is like that, and this is negative, that's why it's acting as an inverting amplifier. And if RF is like say 100k and this one is 10k, R is 10k, then we have a gain of 10. So we can see that the gain is defined by the resistance connected to it, not by the OPAmp's parameter, but the values of resistance is connected to it. This is how we can change the gain of this amplifier. Also we can draw the equivalent circuit of this amplifier, which will be R here, this is Vi plus minus, and here it will be, since this is inverting, we have to change the polarity. The polarity will be like that, RF over R. I have always used R or R1, yeah, R1 I used, so yeah, there are some mistakes here. This will be R1, this is R1 as well, because I have used R1 here, so I'm changing all the R's into R1 just to be consistent with the circuit diagram. R1 here, R1 here, R1, of course the resistance that is connected in the input, so yeah, this one, and this is the output voltage V0 here. So of course the polarity is inverted, and this will be the equivalent circuit of the, and of course this will be like that connected here, because this is ground, of course, otherwise it's just, yeah. So this is essentially a voltage controlled voltage device, but the amplification factor is defined by the ratio of the resistance is connected to it.